today we're going to talk about matrix inverses and solving systems. So a matrix can have an inverse only if it's a square matrix. So the one important thing if we're talking about matrices and having inverses, it must be a square matrix first of all. But not all square matrices are going to have inverses. So if the product of the square matrix and the square matrix A negative 1, which A negative 1 means the inverse. So if we have a matrix A and its inverse, and we multiply them together, then we should get the identity matrix. And a reminder what the identity matrix is: a matrix where if I have a 2 by 2, we have ones in the corners. Or if it's a 3 by 3, then we have ones in the diagonal. So if it was a 3 by 3, then it would look like this: 1, 0, 0, 0, 1, 0, and 0, 0, 1. So when we're talking about trying to find a matrix and its inverse, we have what's called multiplicative inverse matrix. So if we multiply them together, we should get the identity matrix. So here we have a couple different matrices, and they want us to know if the two matrices are inverses. So what we're going to do is we're going to multiply them together and see if we get the identity matrix. So we need our calculator. So reminder how to go to matrices. So a second, and the x negative 1 key here is for matrix. And our first two matrices are 2 by 2, so I'll call matrix A a 2 by 2. And I'll put in 1, 5, 4, and 8. Quit. And our second matrix, matrix B, that's going to be a 2 by 2 also. And then I put in the numbers negative 2/3, 5/12, 5/12, 5 divided by 12, 1/3, and negative 1/12. And so what we're going to do then is we're going to multiply these two matrices together, matrix A and matrix B. So we go matrix A times matrix B. And we multiply them together, and if we get the identity matrix here, so when I do A times B, I get this matrix here, which is the identity matrix. So these are inverses. Alright, so then we'll try that with matrix B. We'll put those in our calculator. It's a little bit harder because they are 3 by 3, so it'll take a little bit longer to put them in. And so we'll go to our matrices and to edit, change our first matrix to a 3 by 3 and plug in these numbers here: 1, 0, 1, 1, 1, 0, and 0, 1, 1. So 1, 0, 1. Alright, and then go to matrix B. And we're going to change matrix B now to a 3 by 3 matrix. So they have fractions here, but I'm going to go ahead and put them as decimals. It'll go a little bit faster. So 0.5, 0.5, negative 0.5, negative 0.5, 0.5, 0.5, 0.5, negative 0.5, and negative 0.5. So once again, I'm going to multiply matrix A and B together, and if I get the identity matrix, so the identity matrix, once again, if it's a 3 by 3, we're going to have ones along the diagonal, like I do here in this first matrix from matrix B, but all the rest of them are going to be zeros. So the thing is I just multiplied A and B together, so on your calculator you can actually just hit enter again, and it'll multiply A and B for you a second time. So now, since since I do not get the identity matrix, so if it was the identity matrix, then there would be a 1 here also. Since there's not a 1 there, then these are not inverses. So to tell whether two matrices are inverses or not, we just multiply them together and see if we get the identity matrix. So now we're going to look at finding the identity matrix. So the inverse matrix. So the inverse of a 2 by 2 matrix A is found this way. First of all, we have to find the determinant. So if I have a square matrix, remember it has to be square for there to be an inverse, and I have the matrix here that's A, B, C, D, then to find the inverse, I have to do 1 divided by the determinant, and then that becomes a scalar, and I'm going to multiply that then by switching these around. Alright, so notice that A and D are switched, and C and B are now negatives. So we're going to switch A and D and make C and B negatives. So here we have matrix A, 4, 3, 2, 1, and we want to find the inverse for that matrix. So first of all, we need to find the determinant. All right, remember, the determinant is equal to, if I take these numbers from the matrix, and then we're going to multiply diagonally, so 4 times 1, and then we're going to subtract 2 times 3. So in this case, we get 4 minus 6 is negative 2. So our determinant is negative 2. So we're going to then take 1 over negative 2, or negative 1/2, and we're going to multiply it by the switching of the numbers. So we have the 4 and 1 are going to switch, so the 1 goes here, the 4 goes down here, and then B and C become negative. So then I just distribute the negative 1/2. So my inverse becomes negative 1/2, positive 3/2, positive 1, and negative 1/2 times 4 is negative 2. So this is my inverse matrix. And so we could check that for sure by taking our calculator and multiplying. So let's go ahead and do the multiplication with our calculator just to check it. So I'll go back to my matrices, make this 2 by 2, and we have 4, 3, 2, 1. And change matrix B. That's a 2 by 2. And matrix B is now going to be our our inverse matrix that we got here. So that's negative 0.5, 1.5 is 3/2, 1 and negative 2. And so then back on my home screen then, I've just been multiplying A and B, so I can do that again. So I just hit enter, and we get the identity matrix 1, 0, 0, 1. So I've just proved that this is my identity matrix, and so I will label that as, I will say that's A inverse. Okay, the identity matrix. So if we have a 2 by 2 matrix, we want to find the inverse. We do 1 divided by the determinant. So the first thing I've got to do is find the determinant. Once I find the determinant, then I will do 1 divided by the determinant, which in this case is negative 1/2. And then I will multiply it by a change of our matrix. So we took our original matrix and we switched A and D. Okay, so the top left, bottom right, we switched them. And then the bottom left and top right, we changed their signs. Alright, so let's look at one more. Right, so we have this matrix here, 4, 3, negative 1/3, 1/4. So once again, the first thing we're going to do is we're going to find the determinant. So the determinant is equal to 4 times 1/4 minus negative 1/3 times 3. So this is 1 plus 1, which is 2. Right? 4 times 1/4 is 1. The opposite of negative 1/3 is positive 1/3 times 3 is 1 also, so we get 2. So we've got our determinant. So to find B inverse in this case then, we take 1 divided by the determinant and then multiply it by our matrix, the change that we're supposed to make in this matrix. So we switch the top left and bottom right corners, and then we make the other two the opposite. So this negative 1/3 becomes a positive 1/3, that negative 3 becomes a or that positive 3 becomes a negative 3. And then we multiply. 1/2 times 1/4 is 1/8. 1/2 times negative 3 is negative 3/2. 1/2 times 1/3 is 1/6. And 1/2 times 4 is 2. And just like with the other matrix we did, we could multiply our inverse we just found with our original one, and multiplying them together, we could, if we get the identity matrix, we know we did it correct. Okay. You can use an inverse of a matrix to solve a system of equations also. This process is similar to solving an equation such as 5x equals 20. By multiplying each side by 1/5, the multiplicative inverse of 5. Now, notice that they were saying multiply it by 1/5, not divide by 5. When you're working with matrices, you cannot divide. You have to multiply by the reciprocal. Right? So you actually have to multiply by the multiplicative inverse. So to solve systems of equations with the inverse, you first write the matrix equation. So we write it as a matrix equation, AX equals B, where A is the coefficient matrix, X is the variable matrix, and B is the constant matrix. So let me show you how that works. So here I have a system of equations, X plus Y equals 8, and 2X plus Y equals 1. Now the thing to notice is that you've been solving systems of equations. We did it with graphing, we did it with substitution and elimination, and now here's another way of doing it using matrices to solve systems of equations. So my matrix A, in this case then, is going to be the coefficients of X and Y. Now notice though, it's got to be written in the correct form. It's got to be written x plus y equals the constant, x plus y equals constant. So my coefficient matrix A here then is the coefficients of them. So the coefficient of x and y are both 1 in the first equation, and the coefficients of x and y in the second equation are 2 and 1. The variable matrix, that's just the values of x and y, whatever your variables are. And you could actually do this with a 3 by 3. And then we have our constant matrix, 8 and 1, which is what we have here, the numbers that are equal to it. So it says to solve ax equals b, we're going to multiply both sides by the inverse of a, so a inverse. Notice though how they have this set up, that it's a inverse times b, it's not b times a inverse. So you have to make sure you do it that way, that we multiply a inverse times b. So we're going to solve this system of equations using matrices. So first thing we're going to do is we're going to write our matrix equation. So our matrix, or our coefficient matrix, there we go. So we've got ax equals b is the equation we're going to do. So our coefficient matrix is the coefficients of x and y, so 2, 5, 5, negative 3. So I took the coefficients up here and I put them down here in the matrix. Then my variables, x and y, and x comes first in my order, so x comes first in there. And then it equals b, which is our constant matrix, so 0 and 31. So we're going to use matrices to find the values of x and y where these two lines intersect. So we're going to go ahead and use you can use your calculator for it, or you can do it by hand by finding the inverse of our coefficient matrix and then multiplying it by that. So notice though, okay, one thing, that this is a, this is a 2 by 2, and this is a 2 by 1. In my matrix, my inverse matrix would be a 2 by 2 also. So if I tried to do b times a, I'd have a 2 by 1 times a 2 by 2, and I can't do that. So when you do the inverse, you have to do the inverse times b. So let's go ahead and take our calculator, and we'll put a in our calculator. So that's a 2 by 2 matrix. And 2, 5, 5, negative 3. So we have our coefficient matrix in there. And now we need our constant matrix. And our constant matrix, matrix B then, is going to be a 2 by 1. And there we're going to put 0 and 31. Now, multiply by the inverse then. When you're doing it on your calculator, it's very simple. So we go to our home screen, go to matrix A, and then inverse is the key right there where the matrix is. So there I now have A inverse. And I'll say times matrix B. Hit enter, and then my solution to this problem is the point 5, negative 2. And I could check those numbers by putting 5 and negative 2 into my original value. So let's look at the very first one. 2 times 5 plus 5 times negative 2 gives me 10 minus 10, which is 0. So that checks. So to solve a system of equations using matrices, you have to first get the coefficient matrix, the variable matrix, and the constant matrix, and then we multiply, to get x, we multiply A inverse times